Here I go. So the first thing we need to define here is this is the last type of sampling method that we're going to learn, kind of. This is called a cluster sample. And a cluster sample is a sample chosen in which individuals are separated into, they're called clusters. Every time I teach this, I think about that cereal with the delicious clusters, like Honey Bunches of Oats, I think. Yeah, so good. Okay, groups typically conveniently located next to each other. This is the most important part. As soon as we write this down, I'm going to give you 3 fun and interesting examples of cluster samples. It's going to be great. An SRS is chosen of clusters, and all individuals in the chosen cluster are included in the sample. Okay, so the process goes like this. Separate population into clusters. Clusters are conveniently located groups. And number them. Separate population into clusters, which are conveniently located groups, and number them. Okay, so for my taco survey, what I did was I separated my data into what period I teach the people, because that would be the most convenient way for me to ask my survey if I was going to do it in person. So my cluster is the period. So I have all the first period of you guys here. And then second period, you guys get what I'm saying? Third, fifth, and sixth. So my clusters would be each class. Okay. Choose an SRS, reminding you simple random sample. That just means that you number them and randomly choose numbers of cluster numbers. So not of students. So it would be like randomly choose period 1, randomly choose period 3. Combine all individuals from the chosen clusters into one large sample. Okay, let me give you 3 real life examples of cluster samples so that you can really distinguish this from the other ones. Okay, first, let's pretend that you're in AC research and your research project is going to be a survey. I want you to imagine you're going to survey, you want to do a survey of the Benicia High School kids, and there's 1,400 of them. And imagine the list of 1,400 students. You have a list of 139 students. That was pretty long, right? Imagine a list of 1,400. And imagine that you do a simple random sample, meaning you choose like student 250 and student 252 and like student 1,900. You got to track all those kids down separately. 1,900 would be too much. 1,400. There used to be 1,900. Anyway, you'd have to track all those kids down separately and ask them to survey. You see how hard that would be? Okay, so what people do for cluster sampling is they would be like, okay, instead of doing that, because we're too lazy, let's list all of the teachers that have a first period class and then randomly sample a couple of classes and then go in and ask everybody in that class. And you see, like, that's convenient. The whole purpose of cluster sampling is convenience. which means that it might end up being a little bit biased. What happens if you pick all AP classes on accident, just by randomness? Or what happens if the opposite, you pick all PE or something, you know what I mean? So it has some bias in it, but is it easier? Absolutely. Okay, let's do another one. So let's pretend that you work for an airline and you're interested in the quality of the airline snacks. Mr. Talbot hates the pretzels. He really is super mad every time there's pretzels. He wants there to be the like Biscoff cookies. He's pro Biscoff cookies, anti pretzels. Anyway, so let's say that you don't want to randomly sample certain people that are flying because that would be really hard. So instead, you list all of the flight numbers for that day, randomly select a few flights, go in and ask everybody on the plane. That's a cluster sample. Okay, next one. You love baseball. I like stadium food. Let's pretend that we want to talk about the quality of stadium food. So think about what is Giant Stadium called now? What is it? Yeah. It'll be something different in 2 years. Okay, anyway, so pretend Mrs. Talbot standing at like second base, and she's got her little list of people she needs to survey. She's got a list of all the seats in the stadium. Just imagine Mrs. Talbot's little legs trying to do a simple random sample. I'm gonna go up here and ask this guy, and then I'm gonna go down over here and ask this guy. You see how hard that is? What if I did a list of the sections instead, like section 1, section 2, section 3, and I randomly sample a couple sections, just go there and ask everybody. Those are cluster samples. Okay, and you're hoping that you can get a little bit of everything from your cluster, but there's going to be some bias just because that's the way it is. Okay, so now we're going to pretend that we're going to kind of do a cluster sample for the taco stuff. So go back to your notebook. And this says, unfortunately, Mrs. Talbot has gone down a rabbit hole with this and now thinks that the easiest thing to do would be to just ask everyone in the same class what their ideal number of tacos is. Use the hat method to select a cluster sample of one of her classes and calculate the average number of tacos in an ideal meal for that class. We're not going to do the calculations just out of time, but let's just talk about how we would do that. Okay, so we're going to number the clusters 1, 2, 3, 5, and 6. And it's 1, 2, 3, 5, and 6 because I have fourth period prep. That wouldn't really be a very interesting class to ask. Are they my quietest class of the day? Definitely. 2. Put identical slips of paper in a hat labeled 1, 2, 3, 5, and 6. Done. I saved my hat from Western Day, and I put identical slips of paper 1, 2, 3, 5. They're backwards, but you trust me? Okay. Never, Mrs. Talbot. You're trying to get certain class selected. Okay, now in this one, we're going to choose one. Most of the time, you would hopefully choose more than one, but just make sure we're just going to put this because you need to make sure you do that when you're doing the hat method. and then calculate the average number of tacos for that class, which would be a sample size of about 30, which is not going with our original 12. But you see, you kind of get more that way because it's convenient. Okay, now I'm going to come around to each of your groups. It's just for fun, randomly sample one of my class periods. All the time, you take thoroughly all of my. You're going to take it, just see what you get. Third period, okay. Perfect. Thoroughly mixing between, it's not mixing. What do you think they would say about tacos? No one's getting first period yet. I do. Second period, freshman again.
I know, they didn't a single.
Somebody did first period. Okay, we like them. They probably like tacos. Six, four, 7, 3. I love it.
So funny.
Actually,
I know,
right.
just gonna burn everyone out.
I thought people like this, but I was like, yeah, that was very fun. I kind of switched.
Okay, no one's gotten first period. It's up to you. It's up to you. Thanks, God, give it. Okay. All right. So, okay. So go back. I know this is really awkward, but go back to your blue sheets. We have one more definition. And sometimes people want to get a really random sample, and they'll do 2 of these. Okay, for example, like they would do a simple random sample of all the students. So they'd have like 100 students and they want 10. So they'd randomly select a spot to start and then choose every 10th one after that out of their random sample. So they do a sample and then they do a sample of their sample. You can combine any of these into more than one. If you really want to narrow it down, this is called multi-stage sample. So multi-stage means you do it in multiple stages. So you could do a cluster sample and then you could like randomly select people from each cluster. You could do stratified sample and then randomly select from the ones that you picked. But if there's 2 or more methods going on at once, it's called multi-stage. Okay, now if you guys could flip back to that first page we did that we never filled in the bullet points. Do you remember it? It's been bothering people, I'm sure, to have this just hanging out. It's probably the best. Yeah. 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 It's just sitting there unfilled out. Okay. Okay, the last thing we're gonna do is just talk about the 3 different ways to randomly select numbers. There's 5 different types of sampling. This is the 3 different ways to randomly select different numbers, like the techniques to use. And I just want to go over these one more time, just to make sure. So Okay, I'm hoping that you're going to see a pattern here. In the hat method, the first thing you do is number the individuals. In the case of, for us, it was the period, and put slips of paper in a hat with those numbers. You could see why this would not be an attractive method if there were a lot to choose from, because I'm too lazy to make that many slips of paper. Draw your sample from your hat, mixing in between each draw. And the chosen slips are your sample. It's not too bad. And do you guys understand what I mean with without replacement? Do you understand what those words mean? Why did we replace them in the one we just did? Because everyone was choosing a different cluster. That was okay. But if you were going to choose two different class periods, you wouldn't want to put, if you chose first period, you wouldn't want to put the one back in the hat because you already picked the one. Okay, just saying. All right, technology. This is also without replacement. Oh, look. The first step is to number the individuals. How odd. Just make yourself a note here. You're going to use rand int no repeat most of the time for this. Okay, last one, table D, your favorite. Oh, how you loved it. Do you remember how much you loved the circling and the highlighting, the repetitive tediousness of table D? We loved it so. What do you think the first step is? I don't know. I'm lost. Probably numbering the individuals. Yeah. Okay, now there's a little bit of a twist on table D. So you number the individuals, but you have to use the same number of digits each time. So example would be like 0, 0, 1 to 139. That's what I mean by the same number of digits each time. If you have a 3-digit number, they all have to be 3-digit numbers. Okay. Choose a random line. Then read consecutive integers, left to right, ignoring repeats and any numbers outside the range. You guys remember how we had a bunch in like the 900s and we had to just ignore those? It was annoying. Okay. Now, can you guys put your notebooks away? You're done with that. Grab your blue pages still though. I don't want that. 1 second. Move on to the blue sheets. The actual lesson for today is just a bunch of vocab again, and it's very quick. So I bet you know a bunch of these. I'm going to be interested to know if there's any Grey's Anatomy fans, you'll know some of them for sure. Okay. Research studies. There are two different types of research studies that we study and that there are observational studies and experiments. So this one says, does not attempt to influence the responses. That's called an observational study. Observational studies observes individuals and measures variables of interest, but does not attempt to influence the responses. So, for example, my survey that I did about tacos was an observational study. I did not try to influence how many tacos that they like to have. I just asked them. All surveys are observational studies. Explanatory variable. The variable that may help explain or predict changes in the response variable. I bet you know what one comes next. The variable that measures the outcome of a study. Response variable. Look at us go when it's already typed out. We just need to fill in the blanks. It's fantastic. Okay. Two variables are associated in such a way that their effects on the response variable cannot be distinguished from each other. This is called confounding variables. Remember the association of murders and ice cream. The increase in temperature or weather was the confounding variable. Remember, correlation does not imply causation. Okay, and last thing here. Experiments deliberately impose treatments on individuals and measure their responses. So one of the things I'm going to ask you to do is distinguish between an observational study and an experiment. So you have to decide, were they just watching and measuring and gathering information, or were they actually trying to change something like a certain treatment and a placebo or something like that, which is what we're doing the rest of the week. By the way, on the block day, we're doing an experiment that I find extremely, extremely fun to watch you guys do. I'm super excited about it. Just something to look forward to. It involves clicking with the mouse, a lot of mouse clicking. my mouse in front of everyone. It's going to be awesome. Okay. The language of experiments. A placebo. A harmless treatment that has no active ingredients but is otherwise like other treatments. Treatment. A specific condition applied to individuals in an experiment could be a combination of different factors. Experimental units. The object to which treatments are randomly assigned. When we have experiments that involve people, the experimental subject units are called subjects. A factor is an explanatory variable that is manipulated and may cause a change in the response variable. And different factors make a treatment. Levels are the different levels of a factor. I'm going to use this language when we do our experiment, and it'll make more sense which thing is which, I promise. Okay, you guys know this one. A group that provides a baseline for comparing the effects of treatments. Control group, nice. Just picture Rod over here. He's teaching right now with his perfect hair. I actually did my hair today. I don't know why. It's not because of Rod. This just reminds me of him. Okay, this group may receive a placebo. Look at all your prior knowledge that you have. Okay, describes the researched fact that some of the subjects in an experiment will respond favorably to a treatment, even if it is inactive. What's that called? I heard it. Placebo effect. Now I have to tell you, this is weird to me. I'm not a person who believes in anything supernatural. I don't believe in anything, like nothing. However, I can't explain the placebo effect and the mind's ability to heal itself. So one spot where I get stuck in that argument. It's weird. Anyway, neither the subjects nor those who interact with them and measure the response variable know what treatment the subject is receiving. It's double blind. Either the subjects or those who interact with them and measure the response variable know which treatment the subject is receiving. Single blind. So that's it. So I actually caught up. That was finishing 4.1b and 4.2a. There's the good news and the bad news. Do you guys already know the good news and the bad news? The good news is I have 2 jokes for you. The bad news is there's 2 homeworks. Okay, I'm going to be flexible about their due dates. I promise you, I know you're swamped. It's okay. Neither of the assignments are very long, but let me show you my 2 jokes to make you happy because I care about your happiness. Okay, this is, I don't know. I have some top 10 jokes. This is one of my favorites. It's a survey question. Are you paranoid? Do you get it? Because
Yeah.
the person's really paranoid. Hilarious. Okay. Here's the next one. 10 out of 10 people that agree that polling only 10 people isn't very good statistical analysis. Also true. Okay,